Hi, this is Tom, and this is lesson 18, and today we're going to talk about variance and standard deviation. So I have here two data sets. I have two data sets, and what I'm going to do is I'm going to graph these. We're just going to use a dot plot. So let's just make a dot plot for each data set. Make a dot plot for each data set. For each data set. All right, so if I do that, well, let's see, here's my first one. And notice, let's see, well, oh, whoopsie, pen just fell. So let's start here. I have 6, 7, 8, 9, 10, 11. Do I need, no, actually that's all I need. Well, this is a very small data set. So notice this, if I have, we'll start at 5, 6, 7, 8, 9, 10. Okay, and then before I go any further, I'm going to copy that. That's a good looking number line there. And make a copy. We'll put that down here just a little bit lower. I'm going to try to line it up even right underneath that. You'll see why here in a bit. Okay, that should work. So let's plot our first data set. So this is set 1. Oops. So set 1 will go on the first graph and set 2 on the second. So here we go. I have an 8, a 6, a 10. What else do we have? Oh, then I have a 7, another 8, and a 9. Oh, and I made a 10 for the 10. I really didn't want to do that. I just wanted to put just a dot there. Okay, that's my first set. Now let's make the second one. The second one has a 7, has a 5, has a 9. Whoa, it has a 13. I'm going to have to go up here. 10, 11, 12, 13, 12, 11. And notice I see a 3 in there, 5. So it's going to also have to go out here to the right. So 5, 4, 3. Okay, so we got to 13. Then we go down to a 3. And finally we end with an 11. Wow. So here's what I want to see. We have two data sets. Each data set contains 6 values. So here, set 1 and is 6, and set 2 and is also 6. But notice that the sets are visually different. And by that I mean, look at set 1, all the data is clumped closely together. And set 2 is spread quite far apart. So let's do this. Let's calculate the mean for each data set. So I'm going to do it this way, x bar, and for set 1, I'll just put a little subscript, a little 1 subscript, and then we'll do the same for set 2. So if I calculate the mean for set 1, I'm going to take let's say I have a 6, plus I have a 7. I'm just taking these from the dot plot, plus another, or plus an 8, plus another 8, plus a 9, and plus a 10. And I divide that by 6, and so this is going to be, let's see, 6 plus 7, that's 13. 13 plus 16, that's 29. 29 plus 9 is 38. 38 plus 10 is 48. So I have 48 divided by 6, so it looks like we have the mean for the first data set is at 8. And so I'm going to put a little triangle underneath that 8, because that's the mean for that data set. And then let's do this the same thing. We'll find the mean for the second data set. Okay, so here again, we're taking the values right off of our dot plot. So I have a 3. Whoops, that looked kind of funny. I have a 3 plus a 5 plus 7 plus 9 plus 11 plus 13 Take all that, and we're going to divide it by 6. So when we start adding these up, I have 3 plus 8, that's 5. 5 plus 7 is 12. 12 plus 9 is 21. 21 plus 11 is 32. 32, let's see, do I have 1, 2? Yep. 32, I think I made a mistake here. Sorry about that. That's 8. Oh, there we go. 8. 8. Sorry, that wasn't a mistake. 3 plus 5 is 8. 8 plus 7 is 15. 15 plus 9 is 24. 24 plus 11 is 35 plus 48. Well, look at that. They both have the same means. Well, what does this mean? Well, let's see. Clearly the data sets are different, and if I was to describe the two sets to you by only giving you the mean of the data set, well, that wouldn't be very meaningful. So here's what we're going to do. What we're going to do is we're going to look at how far the data is from the mean. And so what we're going to do is we're going to do this. We're going to table 1. We'll do this. So we'll do a table for data set 1. Table for 1. And let's say we're going to take the data and we're going to take the mean, and then we're going to subtract the two values, x minus x bar. And I'll show you why. So if I write down my data using my numbers right up here, then I have a 6, a 7, an 8, I have another 8, a 9, and a 10. Okay. And now x bar is the same for all of these. 8. Now, notice that, let's start at the bottom. If I take 10 and I subtract 8, I get positive 2. If I take 9, I subtract 8, I get a positive 1. 8 minus 8 is 0. 8 minus 8 is 0. 7 minus 8, well, that's a negative 1. Now, remember when you write a math formula, you can't just change the order in which you do something. You have to be consistent. So we're always started down below. We always started with the data and then subtract the mean. And that's what this formula, or this right here says. It says start with the data, subtract the mean. And our last one says 6 minus 8. Well, that's minus 2. Well, let's go back up and see what it is that's trying to show us. So notice this. If I look at this first data set, here's my mean. And down below we said 7 was minus 1. So 7 here is 1 unit left. So this is, so minus 1 is 1 unit left of the mean. And when we had 9, well, that had a positive 1. And what that meant is positive 1 is 1 unit right of the mean. So that's what the positives and negatives are telling us, whether it's below or above the mean. Now I want to do something with this. Let's take our data, let's take this data, and let's add up these distances. So x minus x bar, this is the distance from the mean. It's distance from the mean. And actually, you may even want to call it a signed distance, because the sign tells direction, negative being left and positive being right. So if I add these up, I have negative 2 plus negative 1, that's negative 3, plus 0, so we're still at negative 3, plus another 0 for negative 3, plus 1, that's negative 2, plus 2, well, that adds up to 0. Well, when I come up and I look at that first data set, I can look at it and very easily tell you that there's more spread than 0. So how do we fix that? How do we fix this? Well, here's what we do. What we do is we take our x minus the x bar and we square it. Because now that will make all of those distance is positive. Because now -2, if I square it, well, that's 4. -1, I square it, that's 1. 0 squared is 0. 0 squared is 0. 1 squared is 1, and 2 squared, well, that's 4. Now notice all of our distances are been made positive by the squaring. So this, it makes positives, makes all positives. Okay, now if I add these up, I take 4 plus 1, that's 5, plus 0, it's still 5, plus 0, that's still 5, plus 1 is 6, plus 4 more, that's 10. And then, here's what we do. I'm going to tell you what the variance is. The variance that we see above, the variance is the average of the square of the signed distances from the mean. Well, if it's an average, then what we would do is divide by the number of data, and that's exactly what we do. So we're going to say our variance, it's going to equal the 10 divided by the number of data. So we're going to have, this is the same as 5/3, or you could write this as the decimal of 1.6, and it repeats. We'll just round it to 7. 1.7. Now, we have a symbol for it, and we're going to correct this, or put some more criteria on this a little later. But for now, we're going to call the variance, we're going to represent it with this letter, this Greek letter, sigma, and we square it. Sigma squared, that's the Greek letter sigma. And we write sigma squared for variance. Now, immediately, there's something that it's not so obvious, because we didn't really keep track of the units. So, for example, let's come up here to our table where we have -2 units. When we squared it, this becomes units squared. Well, units squared don't make sense in many cases. For example, if I was talking about body weight or the height of people, then you wouldn't need to have the height squared or your body weight squared. So what we do is to fix the units. And so we'll do this. So that the units are correct, take the square root. Take the square root. Take the square root of the variance. This is called the standard deviation. And, let's do this, is represented by sigma. Like that. So, our last step here to find our variance is that we would take, so if we have our standard deviation, well, we would take the square root. You could use the 1.7, but since that's already a rounded number, let's just use the 5/3. And if we take the square root of 5/3, well, let's use Good Grapher and just see what happens. So if I go to Good Grapher and take the square root of 5 divided by 3, it needs a parenthesis, I press enter, and I get 1.29099. We'll round that to the nearest tenth, so we'll call it 1.3. 1.3. I probably should have a wiggle because it is an approximation. And that is how we find the standard deviation and the variance for a data set. This video is about long enough, so in the next video we're going to return and we're going to also calculate the variance and standard deviation for set 2 and just see what our final comparison is. Thanks for watching.